Hi, welcome back. Today we're going to talk about how do you find the domain of a composition of functions. So as we've been talking about in previous videos, we're going to have a function composed of another one. Now when I grab a function, when I graph it, I'm going to have a set of domain values, right? So I have x inputs that exist for that function. Well, what is the domain going to be? For what values am I going to have when I have a function composed of another one? If I have a function inside of another function, will it be for any value, or is it restricted to particular values? So to do this, we're going to do two types of examples. I'm going to show you how to do this on a graph, how to understand this graphically with a calculator, and then I'm also going to show you how to do this by hand, so algebraically. So if you have a calculator, go ahead and pull that out. You can also go to desmos.com and you can graph the things that we're going to do here today. So let's do an example. Here I have two scenarios. First of all, I have function f of g of x, which says f is composed of g of x. I have a function inside of f, right? So the first thing I'm going to do is I'm going to write out what does the equation look like if f is composed of g. So I start with the main function, which is f of x. This function is 1 over x. Now I'm actually going to go into that function and I'm going to replace the x's with a parentheses, because that input will now not be x anymore. That input will be composed of a different function, g of x. And I'll do this in a different color. We're going to put g of x in here, and I'm going to plug in the entire other equation, g of x. That's going to go in here. Now, I don't have space in here, so I'm going to write it again. I have f of g of x. And then the denominator, I'm going to have 1 over the entire function of g of x, which is x squared minus x minus 2. So this is what the equation looks like. Let's go ahead and graph it. So I'm going to graph the function. I'm going to put the division symbol 1 over parentheses x squared minus x minus 2. What does this mean? Well, when I plug in a function inside of another one, as you can see here, we're going to start at negative infinity, but then it's going to get to a point here at negative 1 where the value does not actually exist. If I type in negative 1, x equals negative 1, notice how I'm going to change this to a dotted line so you can see a little bit better. Notice how this line does not get touched by the graph. Notice how that also happens at x equals 2. We'll change this also so we can look at it. Notice that when x is equal to negative 1 and when x equals positive 2, there is no output in the function, meaning that negative 1 and positive 2 are not part of the domain. I can plug in negative 2 and I can get this point. I can plug in 0 and I can get this point. I can plug in 4. I can plug in 6. I can plug in any number I want from negative infinity to positive infinity, except these two numbers, negative 1 and 2. So how do I express that? Well, I'm going to go from negative infinity all the way to this value and not include it. So what's my domain? I'm going to go from negative infinity all the way to negative 1. Now, since it doesn't touch negative 1 and it doesn't exist at negative 1, I'm going to put a parentheses. Union. From negative 1 to 2, I have more values. Right? We can refer to our graph. From negative 1 to 2, I have more values in the bottom. And then there's a gap at 2 again, and it picks up from 2 to infinity on the right side. This is the left part of the graph. This is the middle part of the graph. And this is the right part of the graph. Right? We're going to go from negative infinity to negative 1. There's a gap at negative 1. From negative 1 to 2. There's a gap at 2. And then from 2 to infinity. And that's how we express the domain of a composition of functions. So let's try another one. As long as you're able to plug in a function inside of another and create the composition, we should be able to identify what we're working with. So let's try one more. Here I have g is composed of f of x. So g is my main function. I'm going to be primarily working with x squared minus x minus 2. I first want to identify what the main function is, and then I want to identify which function will be the input. Yeah? So what I do is now that I have identified that the input is going to be f, I can replace the input with a parentheses, right? The x values are my input. So now I'm going to put in there the entire f of x function, which is this one. That's going to go inside of g as the input. So I got x squared minus x minus 2. But instead of x, I'm going to put f of x, which is 1 over x. 1 over x. Yeah? Here, I have g, and inside of g, I have the function f of x. Once you've identified correctly which function goes into the other, I can just graph this function. So let's graph it. What does this look like when I graph it? I put my parentheses, 1 over x. This is being squared, minus parentheses, 1 over x, minus 2. Now from the first look of it, it looks like it goes from negative infinity to positive infinity. But I want to find out if there's a gap here or not. Does it actually exist at 0? So it helps to zoom out a little bit and find out if does it ever connect? Does it ever touch the y-axis? And as you can see, there's always a bit of a gap here, which tells me that there's going to be an asymptote here at 0. It'll never exist. There's a disconnect. We're going to go from negative infinity all the way to 0. There's a gap at 0, and then from 0 to infinity. So if I were to plug 0 into my equation, it would not exist. How do I write that? The function is going to go from negative infinity to 0. Open parentheses, because there's a gap. It doesn't exist at 0. It never touches 0. And then it goes from 0 to infinity. This is the left side of the graph. This is the right side of the graph. So whenever you have a function inside of another one, regardless of the order, we want to take a look at that domain to see what values are restricted. What values can I not plug in because it'll create an undefined value. Now this is graphically, right? If you want to use the graph, you can plug a function inside of another, graph the function, and then describe the domain. I want to show you how to do this algebraically in case you're curious. If you're good by now, you can press pause, stop the video, go ahead and like and subscribe. If you're curious to see how to do it by hand, I'll show you one example of how to do this kind of thing by hand. So here we have another scenario. F of x is the square root of x, and g of x is x plus 5. So I want to describe what happens when f is composed of g. What does that mean? Well, I first need to identify what does that general equation look like? And what does this one look like? A square root function generally looks like this. The parent function starts at 0 and it goes to the right, because you can only take the square root of positive values, or anything greater than 0. The g of x function is going to look something like this. It's going to have a y-intercept of 5. And since the slope is 1 over 1, it'll look something like this. So when I'm doing it by hand, I want to be familiar with what the general graph looks like, right? And I want to define the general functions. The domain for f of x, as you can see, starts from 0 to positive infinity. And I put a bracket because 0, we can actually take the square root of 0, right? Square root of 0 is just 0, and that value actually exists. So I put a bracket. The domain for g of x since it's going from negative infinity to the right, left and right values, we're going to say negative infinity to infinity. Now I want to think. This function exists everywhere, right? So all the values of g of x exist. But if I'm going to plug it into another equation, for what values will it exist on this side? These values don't exist on negative infinity or positive infinity. It just exists on the right side of the graph. So how do I go about it? Now what I'm going to do, since I'm going to put this function inside of this function, I want to figure out for what values does the g equation, which is x plus 5, for what values will it exist in f of x? So I'm going to literally use these two equations together. I'm going to use the g of x equation, x plus 5, and I'm going to use the square root equation. Now the domain of this function is only going to be dealing with positive numbers greater than 0. Another way to say that is I can say everything greater than or equal to 0. So I want to find out, when is g of x greater than or equal to 0? Yeah. So what I do is I solve for x here. I'm going to move the 5 to the other side. X is greater than or equal to negative 5. So I'm allowed to plug in any value greater than or equal to negative 5 into g, which would put it somewhere over here. 1, 2, 3, 4, 5. Right? Anything greater than negative 5 to the right. I'm going to be able to plug in into the g equation in order for it to work in this equation. So what does that look like? What does that mean? Right? When I compose these functions together, f of g of x will look like this. The f function will be the square root function. And inside of the square root, I'm going to replace it with g of x, which in this case is x plus 5. This is what the equation looks like when it's composed of one another. So let's graph that. Right? In our previous example, we were able to graph things and we were able to see how that was true. So let's look at this. We're going to do the square root of the composition. X plus 5. Notice how the domain is from negative 5 to the right, meaning everything greater than negative 5, from negative 5 to infinity. I'm just using the graph to show you what that would look like, right? But in this scenario, we're not using the graph. As you can see, the domain is everything greater than negative 5, or from negative 5 to infinity. So whenever you're doing these by hand, you're going to want to first establish the two domains. And then you want to figure out, if I'm going to plug in g into f, can I plug in all the values? Right? Can I plug in all the values into that function? Well, if this went from negative infinity to infinity, you could plug in any value you wanted. But since it's not, I have to figure out, when does this equation work in this scenario? So I say x plus 5 will only work for when it's positive for f of x. So when I solve for x, it tells me that x must be at least negative 5 in order for this function to exist in this function. I hope this helps. Please let me know if you have any questions. Don't forget to like and subscribe, and as always, we'll calculate.